What's going on, good people? What's going on? It's me. I'm back with another video. Project GTR Mk6. The last time around, you guys got an opportunity to see how that CloudRC software works with sensors. This time around, you'll get an opportunity to see how that CloudRC software works with an actual RC car. The RC car that was chosen for today is the Traxxas 4Tech. The Traxxas 4Tech provides us with a steering servo, an ESC, a motor, and a battery. Your necessary components needed to run an RC car. The ESC, steering servo, brake servo, and continuous servo have all been wired to the PCA 9685 board. Your ESC has been wired to channel 0, your steering servo has been wired to channel 1, your brake servo has been wired to channel 2, and your continuous servo has been wired to channel 3. So I will show you the throttle in the first portion of our test. So let me take a step back, and as you can see, as I press the throttle slightly, it engages. And I can gradually increase the speed. And if I need to, I can immediately, match the throttle and, be launching the car full speed. Next thing I'm going to show you guys is the steering, and that's connected to channel 1 on the PCA 9685 board. So you can see as I turn the wheel on the G29 that the wheels do turn on the RC car. So once again, this is set for a full 900 degrees. Force feedback is enabled, which is cool too as well. Another feature that's been added to the steering is I did set the software up to provide trim. So if the car is drifting left or right, you can use the L2 and the R2 buttons here to adjust that trim either left or right. So right now the trim is set perfectly. I've already adjusted it, but if I needed to, I can adjust it further, or in the opposite direction, I should say. The next thing I'm going to show you guys is the brake servo. Now keep in mind, this isn't going to be the servo that's used for the brakes. This is just simply a servo that is being used for the tests because it does have a servo horn attached to it. And since it does have that horn attached to it, it allows for me to show you guys that as I press the brake, the servo responds in kind. And then the cool part about the brakes is it's set up just like an actual car, where you can actually ease on your brakes as you're coming to come to a gradual stop, or you can slam on your brakes in the event of emergency. And you can see that servo responds in kind to the pedal presses. The last thing I'll show you guys in the test is the continuous servo. And once again, the continuous servo will be used to control the focus of the camera. The ArduCam IMX 477 doesn't have a mechanism that controls the lens so that it can focus, so that it can focus and be controlled remotely. So you have to actually create something for that mechanism. So what I've done is I've attached a continuous servo to channel 3, and I'm going to be using the knob here to control the zoom of the camera. So clockwise, it will send the lens forward. Counterclockwise will will pull the lens back. And you can hear that servo going as I turn the wheel. Let's get that in focus. So that's clockwise. And then this is counterclockwise. So those are the features that I have now. Oh, I forgot to tell you guys, I did set up too as well, lights. So you can see that in the UI. So if I hit square on the wheel, that is going to turn the lights on and off. So I will be setting up a light system for the vehicle. I'm not sure if I want to do signal lights, but I definitely will do tail lights and headlights to start. and this is how the lights will turn on and off. Some updates as far as the sensors are concerned. The INA 260 board has been replaced. The previous board, there were some issues with it. Unfortunately, I don't know exactly what that problem was that was causing the board not to be read by the server code. But since that board's been replaced, it is providing me with the power sensor data that that I'm looking for, which is voltage, current, and power. An update as far as the GPS sensor is concerned. This is being replaced too as well. This is a very, very, very old model in terms of this sensor is concerned. I purchased this about, I would say maybe almost 7 years ago, potentially. And when it was purchased, this was going to be used in another CloudRC project, and that CloudRC project was going to be an autonomous RC plane. I was going to use an F-14. If you guys, go to my Instagram and, scroll down, you'll see that I was working on that, years ago. But this is the GPS module that was going to be used in that, in that RC plane. So since I already had one, there was no need to go out and purchase it, but I actually should have purchased a new one, which I currently did. It'll be arriving tomorrow. This one's a little bit old. It doesn't really connect to the satellites like it used to. And the new one is operating at anywhere from a 10 to 66 hertz channel, and will allow it to connect up to 22 satellites at a time. So huge improvement on that. It's supposedly, the new sensor is supposed to be a lot more sensitive. So that's going to help out immensely in terms of providing that ultimate GPS data that I'm looking for, that latitude, longitude, the speed in miles per hour, as well as, what satellites it's connected to. And then, does it have a GPS fixed position in the event that, a battery dies or something malfunctions, that I can, go ahead and locate that device, the RC car, using this sensor. Some other things that need to be done. I do need to design, I'm actually in the process now of designing the mount for the camera. So that way, the reason why I'm designing the mount first before the actual mechanism to control the focus of the camera is simply because I'm going to be using the Fortec chassis as a means to do my first test runs. The first test runs are going to take place inside the apartment. They're just going to, run back and forth from wall to wall, essentially. And then the next test will actually be outdoors, and there is a sidewalk directly outside of my apartment that spans the entire length of the apartment complex. So I will be using that as a closed drag strip, so to speak, and seeing, how the car fares at 25% throttle, 50% throttle, 75% throttle, and then, the full 100% throttle, from end to end. And I'm going to do a couple test runs with that. And then the other test runs that I'm going to do, the sidewalks that are actually inside the apartment complex are all interconnected. And each one of those sidewalk, and I'm going to use, a select group of those sidewalks as a track. And I'm going to, do anywhere between 75 to 100 laps around that sidewalk, just to make sure that I have sufficient data from the indoor test run, the straightaway test run, and then the closed circuit test run. And once I feel as though I have sufficient data, I'm going to use this 1/10 scale as, the first car that's going to actually go down the predetermined path that I have set for the actual RC car that I'm going to be using for the CloudRC project. And then once I feel as though that I have sufficient data from that, then I'm going to start the process of building the chassis that is going to house all these components, essentially. So the actual RC car itself is going to be a 1/5 scale RC car, and the body that I've selected is going to be this Nissan GTR, but in a 1/5 scale. And in another video, I'll show you guys what that body looks like. The body's absolutely beautiful, and I actually have to do a completely separate video on that because there's some history behind why that body was chosen and why this, and the why of this project starting. So this is going to be the body for the 1/10 scale. I guess it's not primered. This is the color that was, this is the plastic that was under the paint. So I've since stripped the paint off because when I purchased this body, the paint was, scratched up and, fading and stuff like that. So I've set this in an isopropyl bath, peeled all the paint off, and then haven't decided what color I was going to do. I was either going to do Millennium Jade, another rare color, a yellow. I was thinking about doing Bayside Blue or doing a calsonic 1/10 scale like I have in the 1/16 scale, or potentially like a red or a black or something like that. But I don't know. For now, I'm just going to leave it as is because once again, this is just for the test for the 1/10 scale. But like I said, the 1/5 scale is what's going to be the actual car that's going to be used in the project. So stay tuned for that. I'll keep you guys posted as I do, parts, 3, 4, 5, 6, or however many parts this project has, and then you guys will get an opportunity to, come along in this journey with me. If you guys have any questions, comments, obviously put them down below. Like, share, and subscribe. You guys have a great day.